Hello everyone, so welcome to this video. I'm just continuing and doing just lots of examples, and they're getting progressively, I think, more difficult. And so I just try to think out loud to help you understand when you're doing problems what you can do. And a lot of times, sometimes a lot of times things I try don't even work. So that's normal. You know, you start all over again. What I would suggest is don't scribble everything out. Just put a line through it so you know, oh, that didn't work, but now I can go back and see, oh, don't do that again. So here's the fundamental identities that I've used without having to prove, although there are a couple of videos where I explain where these come from and why these are actual identities. And then these are suggestions that books tend to give you to help you out. Okay. So now let's start with one of the examples. So I have sine to the fourth power of alpha minus cosine to the fourth power of alpha, all divided by the quantity sine squared alpha minus cosine squared alpha. All of that's equal to 1. So to me, that's kind of begging me to factor so that maybe one of the factors can cancel out here this denominator. So let's try it. Sine squared alpha minus cosine squared alpha times sine squared alpha plus cosine squared alpha. Right, so that's all I did was work with the numerator. Let me just write down what's in the denominator. By the way, sometimes I see students when they don't have anything to do, let's say work on the denominator or numerator, they just like don't write it. You need to write the entire problem down. It makes it easier for you to understand what's going on. All right, so all I did is work on the numerator, and now we can see sine squared times sine squared will give me the sine to the fourth. The minus cosine squared times the plus cosine squared will give me the negative cosine to the fourth. And then the middle ones are going to cancel out because it's going to be negative cosine squared, sine squared, and then positive cosine squared, sine squared. So what will be left, so we know we factored this correctly. Now what I look and see is, oh, look at that. This is a multiplication. It's, you know, something times something divided by something. So I can cancel out this right here. And what I'm left with is sine squared alpha plus cosine squared alpha equal to, but my gosh, that's one of the fundamental identities. It's one of the most fundamental ones. So I am done. That is the first example. Let's take a look at a second example. 2 minus sine squared theta divided by cosine theta is equal to secant theta plus cosine theta. All right, so I'm going to do something that sometimes you'll see this, but because there's these fundamental identities, this one here is so critical. Sine squared plus cosine squared of an angle is equal to 1, and then you have these forms here. I want to get the 1 here. So I'm going to split off this 2 in 1. I'm going to go 1 plus 1 is 2. And then minus the sine squared theta all over cosine theta. Okay? So here's your 2, and there's your minus sine squared, and there's your cosine theta. So everything's legal. But now at least what I have is, remember this right here, 1 minus sine squared is cosine squared. So I can write this as 1 plus cosine squared theta over cosine theta. Okay? And now I can split this off. If you recall, in another example, you know, if I have 2 terms in my numerator divided by the same denominator, I can split them off. That would be like saying 4 plus 3 over 5 is the same thing as 4 over 5 plus 3 over 5, right? I can do that. So that's what I'm going to do here. 1 over cosine theta plus cosine squared theta over cosine theta, right? Now remember, this is cosine theta times cosine theta, right? Over cosine theta right here. And this is secant theta already. And these cancel out, so I'm left with secant theta plus cosine theta. And that's where I need it to be. Okay. And let's take a look at another example. All right, this looks kind of messy. I'm definitely going to start with the left-hand side because it's got a lot more that I can do things with, right? But I think where I'm going to head is, see how I've got the 1 minus sine theta and then a 1 plus sine theta, and these are fractions and they're being subtracted. So I'm going to have to get a common denominator anyway. So technically I'm going to have to multiply this by 1 plus sine theta and this by 1 minus sine theta. But remember, once I multiply them, I'll be able to say that that's 1 minus sine squared theta and then go into cosine squared theta. So that's where I'm headed. So I'm going to take each one of these and start setting them up to get that common denominator. 1 minus sine x. So I'm going to multiply by 1, right? But I'm going to do it in this form. 1 plus sine x over 1 plus sine x. And then here, minus, let me just write this down, 1 minus sine x over 1 plus sine x. And again, I'm going to multiply by 1, but I'm going to multiply it in the form 1 minus sine x over 1 minus sine x. So again, this denominator now, right, when I multiply, I get 1 times 1 is 1, and the middle terms, negative sine x plus sine x, cancel out, and then the minus sine x times sine x is going to be sine squared x. So what's going to happen here is I'm going to have 1 plus sine x over 1 minus sine squared x plus 1 plus sine x over 1 minus sine squared. And again, I could have written this already all over one denominator. I'm kind of doing more steps just to help you. Now here you have to be very careful. You really have to do this sort of thing because you're subtracting everything that comes afterwards. So if you forget this, it really throws everything off. So here I have 1 minus, oh, I'm sorry. That is actually not correct. When I multiply this times this, I get 1 plus sine x times, let me write that right down. That's wrong. Yeah. See, you can see I already did something wrong. So here I'm going to punt here. This is correct. This step is correct, but I wrote something wrong. When I multiply these two, I get the 1 minus sine squared x. But in the numerator, I get 1 plus sine x times itself, so squared. So my apology. And I really probably should go ahead and multiply that out. I would get 1 plus 2 sine x plus sine squared x. So I'm just showing you how messy this can get. It gets messy even for me, and I've got good dendrites. All right, so that's this part. And over here, I would get 1 minus sine squared, right? Sine x squared. So 1 minus sine x times 1 minus sine x is the quantity, 1 minus sine x squared, all over then this 1 minus sine squared x. So you have to really be careful here. All right, so here the middle terms cancel out and you're left with negative sine squared x. So there you go. So this would be minus, now let's do this, 1 minus 2 sine x, and then negative times a negative is going to be positive sine squared x, and all over this same denominator. Woo! This one's a messy one. All right, so let's go ahead and distribute, even if it is a little bit of work. 1 plus 2 sine x plus sine squared x minus 1, minus the minus is plus 2 sine x, minus times a positive is a minus sine squared x, all over 1 minus sine squared x, which we probably can go into cosine squared. Let's just go say cosine squared already. Go ahead and change it out there. And the only reason I'm doing that is I can see that I'm looking for tangent, which is sine over cosine, and this is over cosine, so that's why I'm heading that there. All right, so we have the 1 and the negative 1. The sine squared x and the negative sine squared x gives me now 2 sine x plus another 2 sine x is 4 sine x, right, in the numerator, divided by cosine squared, right? And we're trying to show 4 tangent x secant x. All right. Sorry, it's so messy. So we're almost there. At this point, I think what I want to do is say that this is 4 times sine x over cosine x times 1 over cosine x. And again, if that bothers you, let's suppose here as an aside, right, I had 4 times, let's say sine x was, I don't know, well, to be honest with you, it has to be a number less than 1, but it's such a pain to do that. So let's say 4 times, we'll do it anyway, 0.75. And let's say cosine squared was, I don't know, 35 squared, so times 0.35. Again, I can rearrange these however I want, right? I can do 4 divided by 0.35 and then multiply by 0.75 and then divide by 0.35, or I could do 1 divided by 0.35 divided by 0.35 times 4 times 0.75. You know, the order in which I do these, this is all commutative and associative, so I can do this. So if you need to play with that, play with some numbers and verify for yourself that this is something I can do. But now I can just say tangent x and secant x. Okay? All right, thanks so much for listening.